Good morning, everybody. Hope you're all fine and safe at home. So let us continue with our section 9.5, Directional Derivatives. So in the last class, we had discussed about the definition of directional derivative. We had also introduced the new vector differential operator, which was the gradient of the function. So in this class, what we are going to do is we are going to give a relation between the directional derivative and the corresponding partial gradient of that function. So how can we do that? Let us see the theorem in your textbook, theorem 9.5.1. It states that if z is equal to f of xy is a differentiable function of x and y, and u equal to cos theta I plus sin theta j, which is a unit vector, then du of f of xy is equal to gradient f of xy or grade f dot u. So let us see how we can prove this. For that, what we are going to do is, first we are going to keep the values of x, y and theta to be fixed. Okay, then we shall define a function, define g of t is equal to f of x plus t cos theta, y plus t sin theta. Now as x, y and theta are fixed clearly, g is a function of only t. What we will do now is that we are going to determine g dash of t using two methods. One is using the normal definition of the derivative, and the other is by using the chain rule. So first let us see what will be g dash of t. G dash of t will be none other than limit h tending to 0 g of t plus h minus g of t by h. Now what is g dash of 0? G dash of 0, we have to put the value of t equal to 0. What will it be? It will be g of 0 plus h minus g of 0 by h. Now what is g of 0 plus h? We will get it in terms of f. What will we get? We get f of x plus, instead of t we have to substitute 0 plus h, that is h cos theta, comma y plus h sin theta minus, what is g of 0? G of 0 will be, instead of t we have to substitute t is equal to 0, that is nothing other than f of x comma y whole divided by h. So do you remember or do you find any resemblance with the directional derivative definition? This was precisely the definition of the directional derivative which we had mentioned in the previous class, that is du of f of xy. Okay, so this is one way of finding g dash of 0. Now let us find the derivative of g in terms using the chain rule. Now g of t was defined to be f of x plus t cos theta, comma y plus t sin theta, right? So g is a function of t only, but f is a function of x plus t cos theta and y plus t sin theta, right? So what will be g dash of t? It will be using chain rule, that is the derivative of f with respect to x plus t cos theta, keeping this y plus t sin theta as a constant. That is, this is like considering the function in terms of two variables, say f a comma b, f of a comma b, that is f is a function in terms of a and b. So what will be it? It will be f of x plus t cos theta, that is derivative of f with respect to x plus t cos theta, into x plus, it's not into, it is t cos theta comma y plus t sin theta, and by chain rule the derivative of this, that is d by dt of x plus t cos theta plus partial derivative of f with respect to y plus t sin theta y plus t sine theta into, using chain rule, it will be the derivative of y plus t sine theta. Now what will this value be? This will be, let me write it on page. What will the value be? The value will be g dash of t will be equal to f of x plus t cos theta of x plus t cos theta comma y plus t sine theta, and it was derivative of this with respect to t. What will it be? X is constant, it will be cos theta plus f of y plus t cos theta, partial derivative of f with respect to y plus t, sorry, this is t sine theta, t sine theta. And what is the derivative of y plus t sine theta? It is sine theta. Now what will be the value of g dash of 0? That is, we have to put t equal to 0 in this above equation. That will be fx, t is 0, so this is 0, fx x comma y cos theta plus fy x comma y sine theta. Now what we are going to do is, we are going to equate these two equations. That is, we had previously calculated g dash of u to be directional derivative of f of xy. This is fx xy cos theta plus fy xy sine theta. Now we can write this as fx xy I plus fy xyj dot product cos theta I plus sine theta j. So this is nothing other than gradient of f of xy, and this is nothing other than our u, which is given in the theorem. So we have proved that du, or the directional derivative of f of xy, is nothing other than the gradient of f of xy dot u. That is the dot product of these two functions. Now these two vectors. Now we are going to see an example in which we will depict how to find the directional derivative using the above mentioned formula. We are asked to find the directional derivative of f of xy is equal to 2x cube x square y cube plus 6xy at a point 1, 1, and the direction of the unit vector whose angle with positive x-axis is pi by 6. So we are given f. First we will find the gradient of f, grade f, that is dou f by dou x will be 4x into y cube plus 6y, and dou f by dou y will be 6x square y square plus 6x. So what will be grade f? That will be 4x y cube plus 6yi plus 6x square y square plus 6xg. Now we are asked to find the directional derivative at the point 1, 1. So we will find grade f at 1, 1. What will it be? 4 plus 6, 10, and 6 plus 6, 12. So this is our grade f. And next we'll find the unit vector. Unit vector, the angle theta is given to us pi by 6. So what will be u? U will be cos pi by 6i plus sin pi by 6j, which is root 3 by 2i plus 1 by 2j. So what is the directional derivative of the function f at 1, 1? It is grade f at 1, 1 dot u. That is 10i plus 12j dot root 3 by 2i plus 1 by 2j, which is nothing other than 5 root 3i plus 5 root 3 plus 6. So this is how we can find the directional derivative using the formula. Now next is also an example. The previous example was much more direct than this question, this example, because here what we have to do is we have to form a unit vector. In the previous example we were given the angle, so we can find the unit vector easily. So let us read the example. Consider the plane that is perpendicular to the xy plane and which passes through the points P of 2, 1 and Q of 3, 2. We are asked to find the slope of the tangent line to the curve of intersection of this plane with the surface f of xy is equal to 4x square plus y square at 2, 1, 17 in the direction of q. That is the only thing that we have to find extra. This we are given the function f of xy and we are given the point 2, 1, 17. So we can easily calculate the grade f. Then we need to have a unit vector to find the directional derivative. So for that, what we are going to do is we need it in the direction of q. So that is we'll find the vector pq. What will be pq? Pq will be the vector. We are given 2 points 2, 1 and 3, 2. So what will it be? 3 minus 2, 2 minus 1, that is 1, 1. So PQ vector is I plus J. Now note that this PQ vector is not unit vector. So we have to make it unit vector. How can we find a unit vector given any vector? We just have to divide it by the magnitude, right? So what will be the magnitude of this? This is 1 square plus 1 square root, that is root 2. So we will find a unit vector u which is equal to 1 by root 2 I plus 1 by root 2 j. Then we are going to find the grade of f, that is 8xi plus 2yj, and at the point 2, 1 here 17 is irrelevant. So grade f at 2, 1 is 16i plus 2g. So what will be the required slope? It will be the directional derivative of f at 2, 1, that is 16i plus 2j dot 1 by root 2i plus 1 by root 2j. So I hope it is clear. In the difference between the previous two examples, the example 3, last example was a direct question. We were given a function, we were given a theta, so we can find what is u, this is a unit vector, and we can also find grade f. Then this grade f we can easily find because the function is given to us, and using the points given to us p and q, we are going to form a unit vector by dividing it by the magnitude. And most of the problems need not, the vector given to us need not be the unit vector, so we just have to divide it by the magnitude to form a unit vector. Now next we are discussing the concept of directional derivative for functions of 3 variables. The directional derivative is defined by du of f of x, y, z is limit h tends to 0, f of x plus h cos alpha, y, y plus h cos beta, z plus h cos gamma minus f of x by z by h. Similar to that of a 2 variable case itself, where alpha, beta and gamma are the direction angles of the unit vector measured relative to the positive x, y and z axis respectively. Now as we proved earlier, we can also show in this in case of 3 variables that the directional derivative of f with respect in the direction of u is nothing other than grade f of xyz dot u. So let us see an example which depicts the case of 3 variables. Find the directional derivative of f of xyz equal to xy square minus 4x square y plus z square at 1, minus 1, 2 in the direction of 6i plus 2j plus 3k. This everything is given to us. The surface is given to us, point is given to us, also the vector is given to us. Now first we will check whether the given vector is unit. We can easily say that it is not unit because root of the magnitude is not 1. So we are going to divide it by the magnitude. What will be the magnitude? It will be root of 6 square plus 2 square plus 3 square. That is 36 plus 4 plus 9, that is root of 7. What will our unit vector be? We have to divide this given vector by 7. That will be 6 by 7i plus 2 by 7j plus 3 by 7k will be the unit vector. Then we can find the grade f. That is what will be grade f? Grade f will be y square minus 8xyi plus 2xy minus 4x square j plus 2zk. And what will be the grade f at the point 1, minus 1, 2? The value will be 9i minus 6j plus 4k. So what is the directional derivative? We have to find the dot product of this vector and the unit vector u. That is 9 into 6 by 7 minus 6 into 2, that is 12 by 7 and plus again 12 by 7. So altogether we'll get 54 by 7. So this is in this section we had discussed about what is we had discussed a method to find directional derivative in a easier manner using the gradient function, using the gradient of the given function. So the directional derivative was du of f of xy is equal to grade f of xy dot u, where u is a unit vector. So you have to just keep in mind that the vector that we are considering must be unit vector. So if we are not given a unit vector, we have to make it a unit vector. So that's it for today's session. Thank you. Stay home and stay safe.